Chapter 5. So Chapter 5 deals with the other thing you do in calculus, which is integration. So far we've done derivatives. So now we get to the other part. So antiderivative. So given something like this. So given that the derivative was x squared, we want to know what was the antiderivative. So the antiderivative would have been x cubed over 3 plus some number. Okay? So we get to this symbol, which is for integration. So some of the basic rules for integrals then is given x to the n dx. This becomes x to the n plus 1 over n plus 1 plus c. Second one, integral of e to the x is e to the x plus c. And the third one, integral 1 over x dx is the natural log of x plus c. Okay. So this one, n cannot be -1, and here x cannot be 0. So let's look at an example. Let's say I had this, integrate 4x cubed 7x squared plus 8x minus 1, integrating with respect to x. Then this is going to give me 4x to the 4th over 4, 7x cubed over 3, 8x squared over 2, minus 1x over 1 plus c. This can be simplified. X to the 4th, 7/3 x cubed, 4x squared minus x plus c. Right. Let's look at another example. Integral of 4x to the 7th, 3 times the 4th root of x cubed, 9 over x to the 4th. So the first thing we want to do is rewrite this, get everything on the same line. So this is going to be x to the 4th thirds. This will be 9x to the minus 4th. Right. Now that we have it there, we can do our integral. So this is going to be 4x to the 8 over 8 minus 3 times x to the 7/3 over 7/3 plus 9x to the minus 3 over minus 3 plus c. And we can simplify. And so this will give us x to the 8th over 2 minus 9/7 x to the 7/3 minus 3x to the minus 3 plus c. All right. So then in terms of a business example, so given that the marginal cost, so c prime, was 0.3x squared plus 2x, then c of x would be the integral of my derivative. So I can integrate 0.3x squared plus 2x. So we integrate this, we get 0.3x cubed over 3 plus 2x squared over 2 plus k, which becomes 0.1x cubed plus x squared plus k. Okay. And your book uses a k for the constant for this one instead of a c, because we already got c for our cost. And so now if we're told that if c naught is equal to 4,000, then we would have 4,000 equals 0.1 times 0 cubed plus 0 squared plus k. So k equals 4,000. And so our cost function is going to be 0.1 x cubed plus x squared plus 4,000. So we had derivatives. So let's say we start out with f of x equals 4x squared plus 9x plus 3. Then my derivative is going to be 8x plus 9. And then we can get to the thing called the differential. And so the differential is just dy is going to equal 8x plus 9 times dx. So that's basically what makes the differential. Okay, so basically then in general terms, dy is going to equal f prime of x dx. Right? Well, it ends up that derivatives and integrals are the opposite of each other. So if I integrate both sides here, if I integrate this, we integrate this, this becomes y equals 8x squared over 2 plus 9x plus c. So y equals 4x squared plus 9x plus c. And then if we have whatever information that went with my original, we can figure out what the c is. Right? So some of the methods they talk about then here is one of the methods is substitution for doing integration. So given something like this, 4x squared well, the first thing you want to do is rewrite it without that radical. So this is 4x squared times x cubed plus 5 to the 1/2. Right? So now we're going to do substitution, all right? So we're going to use u, okay? And so we're going to say that u is going to equal x cubed plus 5, right? Which means then the du would be 3x squared dx. So we want to pick the u such that the derivative is going to closely match the other term, right? And here, my original other term is 4x squared. This time we get 3x squared, right? So now if I do my substitution, so this is going to be u to the 1/2. My du is 3x squared. My original was 4x squared. And so the factor I need to multiply by in order to go from 3x squared to 4x squared is going to be 4/3. Right? And the way I can get the factor is just take whatever we had originally, which was 4x squared, divided by my du, which is 3x squared, and this gives me 4/3. So now I get something here I can integrate, and so this is going to be 4/3 u to the 3/2 over 3/2 plus c. And so this is going to become 8/9. We take the u out, put our original back in. And we have our, okay. So a little bit more on differentials. So differential equation. So they do a little bit on differentials in this chapter. So given dy dx equals 6x squared minus 4x, right? So this would be a first order differential. And it has to do with the derivative. This is the first derivative. So we can have first order, second order, third order, so on. Right? So given something like this, x minus 3 dy dx equals y plus 4. Right? And so the question then is y equal to 5x minus 19 a solution. Right? So that would mean here my derivative is going to be 5. So this would be x minus 3 times 5 equals 5x minus 19 plus 4. So this is 5x minus 15. Does that equal 5x minus 15? And of course here the answer is yes. So now we talk in terms of exponential growth or decay. So equation then, so dq dt is r times q, and q of 0 equals q naught. And so then my equation is q equals q naught e to the rt. So given something like this, so given that the world population reached 7 billion in 2011 and was 6 billion in 1999. So Q naught is going to equal 6. Q after 12 years was 7 billion, and T is going to be 12. So that would mean we can get the rate of growth. So 7 equals 6e to the 12r. So we can divide by 6. So 1.1666 equals E. R. Then we can take the natural log, which is the opposite of E. So the natural log of 1.1666 equals 12R. And then we can divide by 12. And we get R 0.0128 equals R. So now if I want to know what is the world population going to be, in 2050, then we'll have Q equals 6E 0.0128. 2050 is 51 years after 1999, and we get here 11.53 billion people on the planet in the year 2050. All right. So you have indefinite integrals, which is where you get the plus c. The other part then is you get to this thing called a definite integral. So now we're going to integrate from a to b So, for example, if we integrate 0 to 3, x squared dx, this will be x cubed over 3, evaluated from 0 to 3. So this is going to mean 3 cubed over 3 minus 0 cubed over 3. And this will be 27 over 3. And we end up with an answer of 9. So you get what is called the fundamental theorem of calculus. So if I integrate a to b of f of x dx, this is going to be the f of b minus the f of a. So then, in terms of problems, so let's say we have this one. We got that the marginal profit is given by 165.1x, and x is in between 0 and 4,000. Okay. And I want to know what is the change in the profit if production goes from 2,000 to 3,000. Okay. So we're going to integrate from 2,000 to 3,000. 165 minus 0.1x. So if we integrate this, it'll be 165x minus 0.1x squared over 2, evaluated from 2,000 to 3,000. So this will be 165 times 3,000 minus 0.1 times 3,000 squared over 2 minus 165 times 2,000 minus 0.1 times 2,000 squared over 2. Okay. So if I do this out, this ends up being 495,000 minus 450,000 This is 330,000 minus 200,000. So this is going to be 45,000 minus 130,000. And so here we end up with a final value. So here what this tells me, in the case of this scenario, if we go from 2,000 to 3,000, we're going to end up losing $85,000. So that change would not be good. And then the last thing here is called average value. And so this is given by 1 over b minus a integral a to b f of x dx. So given that f of x is 3x plus 4x squared, and my interval is going to be from 4 to 7, and this will be 1 over 7 minus 4 integral 4 to 7, 3x plus 4x squared dx. So this will be 1/3 And then this will be 3x squared over 2 plus 4x cubed over 3 evaluated from 4 to 7. So this will give us 1/3. 3 times 7 squared over 2 plus 4 times 7 cubed over 3 minus, let's put these in parentheses. Oh, this would be 3 times 4 squared over 2 plus 4 times 4 cubed over 3. Okay. So it'll be 1/3. Start number crunching this all out. So this is going to give you 147 over 2. This will be 1372 over 3 for that part, minus, and then on this side, actually get rid of this bracket here. All right, that's better. So on this side, we'll have, this will be 24 plus 256 over 3. Again, or the add or subtract, we need to have a common denominator. So this one is going to give us 3185 over 6. This side will give us 328 over 3. And then when we do that out, we'll end up with 1/3. This will be 843 over 2, which will simplify to 281 over 2. Okay? And that will conclude this video.